Hello and warm welcome. This is lab number 22. The title of this lab is Optical Alignment Techniques. Laser beam alignment is an important practical skill that every photonics technician must acquire. It turns out that aligning the laser beam is not an easy task. It requires a lot of patience and personal touch, a good coordination between your eyes and your hands. But the good news is that this skill can be acquired through a lot of practice. So in this lab, we are going to be practicing this important skill. It's also important to mention that alignment of the laser beam is very important in many applications because manipulation of the laser beam requires a lot of good positioning of different types of optics, such as focusing optics, beam shaping optics, as well as the alignment of the laser beam that's going to be passing through that optics. There's a few other things that need to be mentioned. One important aspect is the laser safety, because when you are aligning the laser beam, you may be moving in front of that laser beam, and you want to make sure that you have incorporated proper laser safety procedures so that your eyes are not at the risk. The whole aspect of laser safety has been covered in the lab 1. And now that we are talking about the laser safety, it's also important to mention that you should not only be worried about the direct laser beam, but also different types of reflections, both specular and diffuse, that may be produced by different objects, including the jewelry on your hands. So you want to make sure that you remove any kind of jewelry or other objects, metal, especially metal objects that may be on your hands, since those objects may produce the reflections that may pose laser safety hazard. We are going to use the following equipment in this lab: our red laser diode module, a laser holder, a target card with a cross, a lens holder to hold the target card, and here I have a blue filter to be used to dim my laser beam so that I can achieve better contrast on my recording equipment. I'm going to use the lens holder to hold this filter. And finally, here I have a whole bunch of small cards. These cards are of a thickness of a 1/16 or 1/8 of an inch and size of a 1/2 inch by 2.5 to 3 inches that are going to be used to put under the laser holder during the process of a laser beam alignment. Here's the lab setup for the lab 22. As you can see, I have mounted my laser module here on a laser holder. And then here in the back, I mounted my index card with a big cross target onto the lens holder. Here in front of the laser, I mounted a small filter onto a lens holder as well to dim the laser light that's coming out of my laser module. This laser is a 5 milliwatt laser, so it's producing a pretty strong light that is creating a lot of specular reflection. So if the light in the room is dimmed, it's not easy to establish a contrast on my camera. So that's why this filter is positioned here to reduce the intensity of the light behind so that we can better see the laser beam hitting my index card. Now what you can see here is that our laser beam is hitting the index card right there, which is kind of below this target. The goal of this lab is to align the laser beam so that it is hitting the cross exactly at the center on our target card, no matter where this index card is positioned, how far it is away from the laser. So the alignment is going to consist of adjustment of the elevation, where you're going to be taking this laser, moving it up or down, or changing the tilt, meaning changing the direction in this way. The way how this is being usually done in a photonics lab is using something called scissors jacks. So you would put one scissors jack here in front, another one in the back, and then you're going to be changing elevation of those two scissors jacks. That would be basically changing the tilt as well as the elevation of your laser. So since we are trying to present here an affordable way of aligning the laser beam, instead of the scissors jacks, I'm going to use a whole bunch of small cards. So the first that I'm going to do right now is I'm going to elevate my laser so that it hits the center of the cross on my index card. And I'm going to elevate both the front as well as back of my laser holder. So to elevate my laser beam, I'm going to be using these cards, as I already mentioned. And it looks like I'm going to need about 4 to 5 of these cards of this thickness to elevate the beam to hit the cross on the index card. Okay, we have definitely improved the elevation of our laser beam, but still it's not hitting the cross on our target card. So we need to add more than a stack of 5 cards. Before I do that, I'm also going to elevate my filter so that laser beam hits the center of the filter. So I'm going to add 4 more cards to increase the stack of the cards used to elevate my laser beam. Okay, now that we added 4 more cards on each stack of my elevation cardboard cards, you can see that we have achieved a pretty reasonable alignment, meaning our laser beam is hitting the center of the cross. Now the next to check is if this laser beam is running parallel to my workbench, meaning if I take this target card and move it away from the laser, I want to see if I'm still keeping the same alignment, meaning my laser beam is still hitting the center of the cross. So what I'm going to do now, I'm going to take this target card and move it away. So right now it's about 7 to 8 inches away from the laser aperture. So I'm going to move it now away from the laser aperture and see if the beam is still aligned. Okay, now that my index card is moved away from the aperture, you can see that my laser beam is actually not hitting the center of the cross anymore. It looks like it's hitting somewhere below the cross, which means that the tilt of my laser beam is not adjusted. So we have adjusted elevation at a certain position of the index card close to the aperture of the laser. However, if we move away, it means that my laser is tilted downwards, meaning it's hitting the bottom side of this cross. So let's try to add one card to the front to elevate the beam upwards at the position of the index card away from the laser aperture. So after we added one extra card to the front of our laser, it looks like our laser beam moved up too much. So it looks like the cards that we have are not providing us enough of resolution, meaning they are too thick. So what I did is I produced different type of a card from a little thinner cardboard that we're going to use to provide for a better resolution. So let's remove the thick card from the front and then put one of these thinner cards and see if we can achieve better alignment. By adding thinner card to the front of our laser, you can see that we achieved laser alignment. So when our target card is about 2 feet away, we have a perfect alignment. Now the next step is to take this index card, this target card, and move it again back to the position close to the aperture of the laser and see if we lost the original alignment that we achieved when the target card was right at the front of the aperture. Okay, now you can see that we barely lost the alignment of our laser beam when the target card is close to the aperture, so our laser beam is hitting slightly above the center of the cross. So at this point we would want to add one thin card to the back of our laser. And by adding one thin card to the back of the laser, we have again established the alignment of the laser beam. Now we're going to again slide our target card away from the laser aperture and see if we are still having a reasonable alignment of the laser beam. So as you can see, our laser beam is again slightly misaligned, meaning hitting a little bit below our target. So again, you would want to add a thin card to the front of the laser to move it up. And you would basically want to continue with this process of sliding the target card back and forth, or closer or farther away of the aperture of the laser, and adjusting the stack of the cards under your laser holder until you achieve full alignment of the laser beam, meaning your laser beam is always hitting the center of the cross on the target card. That's not a function of the position of the target card. So this whole procedure, laser alignment procedure, consists of multiple iterations of moving the index card back and forth, and then, as I said, aligning the laser by elevating its front or its back. This is an important practical skill that requires patience from a photonics technician, but is very often used in a photonics lab where a certain optical system that consists of a laser as a source is used.